Hey guys, welcome back to the next video. In this video, we are going to understand more details about your namespace and Cgroups. Now, remember that this is a process which is already by default enabled at your kernel level, so you don't really have to enable this in any way or form. But do remember that you need to have virtualization enabled if you're using a VMware virtual machine and you're planning to do it on your laptop. By default, the Windows has the virtualization enabled at its end, so which means that you will be able to use these virtualization Docker kind of technology and then create Dockers in your Windows. So if you want your virtual machine like a Linux virtual machine you're creating using VMware and you want it to actually have the Docker created through a VMware virtual machine, you first need to disable the Windows one and then enable that on your VMware and then use that particular virtual machine for virtualization and Docker container creation. Until you do that, it's not going to work. Now let's dive in deep into this training where we are going to, or we are planning to create a Docker-based containers on our virtual machines. So in our training, we'll be using our laptops, just that I want to give you a heads up. In this scenario, what I'm going to discuss is that there are these two important kernel features called namespace and control groups or Cgroups, which is commonly called. And these are the properties which each one carries in terms of creating your container. So this is what we are going to look at in this video. In the Docker world, namespace and control groups are two important Linux kernel feature and that provides isolation and resource management and allocation for containerized application. These features are fundamental to containerization technology like Docker, and are used to create secure and resource-controlled environment for your container. So we will see the overview in terms of each one of them. First, let's understand what's a namespace is. Namespace are Linux kernel feature that provides process and resource isolation for containers. Docker uses several types of namespace to achieve isolation between containers and between the host as well, host systems. So, which means that it is not isolating between containers, it is also between container and the host system, which is the sys system. For example, in our system, this is my laptop where I'm using Windows operating system. And within that, I have an option of either use the Windows operating system as the host system and use the Windows kernel feature to achieve the similar kind of option and then create Docker containers from there. Or I can use my virtual machine called VMware virtual machine and then enable containerization or virtualization in that virtual machine and then create Docker engine there or install Docker engine and then create Docker containers using namespace and Cgroups. So these are the two options available for me. I will show you the Linux option, but later when I have time, I will show you the Windows option as well. So do not worry about that, but Windows option is going to be much easier because of Docker Desktop. Again, it runs with Docker Engine, but we don't directly configure Docker Engine. We will be using the Docker Desktop to configure the Docker Engine, which actually runs on the background in terms of Windows. But in Linux, we will be directly using Docker Engine. All right, so let's go on explaining about the namespaces. So the first one is PID namespace. Isolate the process ID space. Each container has its own PID namespace, making it appear as if it has its own isolated process tree. Next one we are going to talk about is mount namespace. Provides an isolated file system view for each container. Containers have their own root file system separated from the host and other containers. Network namespace. Isolated network interface, routing tables, and firewall rules. Each container has its own network namespace, allowing containers to have their own IP address and network configurations. The next one is about IPC namespace. IPC is called Inter-Process Communication. It isolates the inter-process communication resources such as message queues and semaphores. Containers in separate ICP namespace cannot directly communicate with each other through these mechanisms. The next one we are going to talk about is UTS namespace. The UTS namespace isolates the host name and NIS domain name. Containers can have their own unique host names. The next one is user namespace. User namespace provides user and group ID mapping. This allows a container to have its own users and group IDs separate from the host. Namespace ensures that the process running on containers are isolated from the process running on other container or from its own host system, providing a level of security and isolation. Now let's talk about the Cgroups. The first one we are going to talk about is resource allocation. Cgroups enables you to allocate and limit system resources such as CPU, memory, block I/O to containers. This ensures that one container cannot consume all the valuable resources, leading to a fair resource sharing among containers. The next one we are going to talk about is resource isolation. Cgroups isolate the resource usage of a container from each other. This means that the behavior of resource-intensive container won't negatively impact other containers or the host systems. Let's talk about monitoring. Monitoring on Cgroup provides metrics and statistics about resource usages for each container, allowing for monitoring and reporting to happen simultaneously. Now, we have professional monitoring tools which we can integrate with this particular functionality of your kernel and then gather the monitoring and reporting metrics from these containers and then put it in a graphical format. The next one we are going to talk about resource enforcement. Docker uses Cgroup to enforce resource limits defined in a container configuration, preventing container from exceeding the allocated resources. Now remember that this resource enforcement comes as part of Cgroups, and then Docker takes the advantage of using this resource enforcement to enable the feature. In summary, what we have seen so far is namespace gives you the process and the relevant resources about the process allocations, and it also isolates those process limitations, especially for PID, file system, networking, and then communications towards the other peer services, peer containers, and then you have your own user namespace likewise. And in terms of control group or Cgroups, monitors resource enforcements and allocation of resources like CPU, memory, hard disk drive, so forth. And then isolating those resources from other containers and from the host system is all part of the Cgroup. Now that you understood about this, I think you're ready to go ahead a little more in detail about the Docker and other components which the Docker utilizes. Thanks again for watching this video. I hope that this is really helpful for you. Please leave your comments on the comment section. Your review matters. So if you have anything which I've covered which you need more explanation towards it, or you need a specific topic to be covered and explained in detail, you can leave a review with that thought. But your every 5-star review is going to encourage me more and going to make me create more interactive content for you. Thanks again for watching this video. I'll see you on the next one.